Good morning, students. As this welcomes you all. In the last lecture, we have discussed about the mechanism of flow of current in a conductor. Now, here we are going to introduce our new topic, that is drift velocity. That is drift velocity. What is this drift velocity? We have to study here, and what is the significance of drift velocity, where it is used, and how necessary it is. We have to discuss all these points here. So, as we all know that a conductor is made up by large number of electrons and they do random motion in that conductor, so that the average velocity of the conductor remains zero and the current inside the conductor remains zero. But when this conductor is connected to an external source which is supplying the potential difference across the conductor and developing the electric field inside the conductor, so what happens in that particular case? Let us discuss. We are taking a conductor which is made up by large number of free electrons. Until any external source is applied over this, the electrons are moving here and there. But what happens when electric field is generated over it, or the external source is applied over it? The electric field is generated inside the conductor, and these free electrons which are moving randomly here and there, they are moving in a particular direction. They are moving in a particular direction and current develops. So the average velocity by which these electrons are getting drifted towards the direction, or you can say that towards the positive end of the battery, or opposite to the electric field, we can say, that is called drift velocity. I'm repeating my words. What is that? The average velocity with which free electrons are get drifted towards the positive end of the battery, or you can say that the opposite to the electric field, that is said to be what? Drift velocity of free electrons. I'm writing it here. Just look at here. The average velocity. What I'm writing? The average velocity with which free electrons are get drifted towards the positive end, of the battery or opposite to the electric field is said to be drift velocity. Is said to be drift velocity of free electrons. So here we have discussed about the drift velocity of free electrons, and it is denoted by Vd, V and suffix D. So what is the formula of this? How does it relate with that? So expression we'll discuss in the classrooms, and here we are just going to discuss what is the formula of this. So the formula can be given like Vd is equal to minus EE upon m tau. This minus is for the force experienced by the free electron in a conductor which is opposite in direction of the electric field. That is why I'm using minus sign here. But we can also solve it further. Then it can be written like Vd is equal to minus EV upon ml tau. From where it comes? Look at here. As we know that since V is equal to ED, and if we are taking this conductor as of small l length, so we can write V is equal to E into L. Since E can become V upon L, we are putting this in this particular and we are getting this one. These are the formula generated for the drift velocity. Moving further, effect of temperature. effect of temperature on drift velocity. What is the effect of temperature on drift velocity? We have to discuss this point here also. As we know that Vd can be written like what? Minus EE upon m tau, and we have discussed why minus is used here. If I'm not writing minus here, that it would write EE upon m tau. From here we can say that Vd is directly proportional to tau, and here tau is what? Tau is relaxation time. Earlier we have discussed what is relaxation time. The time taken between two successive collisions can be said as relaxation time. So here Vd is directly proportional to tau. So we can conclude that when temperature of a conductor increases, the electrons move faster, and collision between electrons become more rapid, so that relaxation time what? Decreases. Tau decreases, because if they are colliding in very short period of time, then the relaxation time will decrease. So here tau decreases, and hence we can say that with the increase in temperature of a conductor, drift velocity also decreases. Drift velocity also decreases with increase in temperature of a conductor. Now what happens to the significance of this? Let us discuss the significance of drift velocity and relaxation time. Here we are going to discuss that what are the significance of this. So significance of drift velocity and relaxation time. Let us first talk about drift velocity. Why it is used? Drift velocity controls, remember always, it controls the net flow of charge across any cross section of a conductor. And what about relaxation time? Let us discuss here. Relaxation time. What is the significance of relaxation time? It determines the drift velocity acquired by the electrons under the effect of applied electric field. So here we can conclude that Vd is directly proportional to tau. So the graph between Vd and tau can be written like what? this won't be a straight line. Like this one is indicating Vd and this one is indicating tau, then we'll get that a straight line. But what about with the temperature? Vd is inversely proportional to the temperature. Then the graph between Vd and T, the graph between Vd and T can be given like what? When temperature is increases, Vd becomes lesser. So this one is with the increase in temperature, Vd becomes low. So this one is all about that significance of drift velocity and relaxation time. I hope you are getting all these points and you'll be understanding all these points very carefully. As this, will see you again in next lecture. Stay safe and take care.